Welcome to the lecture series on the topic steam generators and steam turbines from the subject thermodynamics and heat transfer. So we have already seen what is steam, how steam formation takes place. Then again, in the formation of steam, we have studied what is sensible heat and latent heat concept. Now today we will see about the Rankine cycle. So steam generation is the fundamental process in power plants where water is converted into steam using heat energy. And we are going to discuss the Rankine cycle for this thermal power plant, which we also can call it as a steam power plant. So basically, the thermal power plant consists of several important components such as boiler, turbine, condenser, and pump. So we can see here it is a closed loop system. So this entire system can be converted into four process. So we are going to discuss this process in detail. So let first see about different components of the power plant. So we will be starting from this element, that is boiler. So as we know that boiler, we are converting water into steam in this region. So the first part, that is boiler, the working fluid receives the heat by combustion of fuel and it is converted into steam. So here in this diagram you can see that this QA is the amount of heat which is added or provided to the boiler through the combustion of fuel. So due to this heat, water will gain heat and it will be converted into steam. So this TH, it represents the temperature of the steam, and once the steam is formed, it will be taken out from the boiler and it will be then supplied further to the steam turbine. So here comes the second component, that is steam turbine. In steam turbine, steam from the boiler pressure expands to deliver work of expansion. So this means that whatever the steam we are having from the boiler, once it passes through the turbine, we will be having here expansion process. That is, as the steam will pass through the blades of the turbine, it will provide us with the mechanical energy. That is, we will be having one shaft which will rotate here, and there will be a pressure drop. There will be a large pressure drop, and this steam that is coming out of the turbine will be further passed to the next component, that is condenser. So here whatever the mechanical energy is obtained from the turbine, it is fed to the generator where the mechanical energy is converted into electrical energy. So this WT represents the amount of work which will be obtained from the turbine. That is the mechanical energy. Now comes the third component, that is condenser. So in condenser, the exhaust steam from the turbine gives heat to the cooling water and it is completely condensed to the water. So here as the condensate which will come from the turbine, it will further pass into the condenser. So this condenser is actually a simple type of heat exchanger. It will be a non-contact type of heat exchanger. So here we can see one simple tubes through which cold water is actually circulated. So here there is actually one more component which we call it as cooling tower. So the cooling water is obtained from this cooling tower and it is circulated through this coil which is placed inside the condenser. And as this cold water is circulated and at the same time the hot water from the turbine will be entering into the condenser, so heat exchange process will take place in between these two fluids. So as a result, the steam which is coming from the turbine, it will the heat that is present in this steam, it will be absorbed by this water which is coming from the cooling tower. So the temperature of this cold water will further increase and it will be again fed back to the cooling tower for cooling purpose. So now we are having the condensate which is in the liquid form, and we are providing this condensate from condenser further towards the feed pump. So this is the fourth component, that is feed pump. So here the feed pump, it feeds the condensate from hot well to the boiler at boiler pressure. So whatever the condensate we are obtaining from the condenser through this feed pump, we will be recirculating back that water in back to the boiler. So in this way, we can see the path of steam is completed, and whatever the steam we have formed in the boiler, it will pass through several components, and again it will return back to the boiler. So this was related with the different components that are present in the steam power plant or thermal power plant. Now we are also going to discuss about the four different processes that are associated with the different components that we have discussed now. So we will be seeing those processes in detail. So just to simplify or to understand each and every process, what we have done, we have divided this entire cycle into four parts. So you can just refer the numbers here. That is this 1, 2, 3 and 4. So with the help of these numbers, we will be explaining each and every process in the further slide. So to understand these four processes, we are also going to refer the PV and TS diagram, which will help us to, or it will help us to understand how the process are changing from one component to the other, or what is actually happening in that process. So here you can see this. First we are having a three diagram. So this diagram is the previous one which we have just discussed now, and these two diagrams, the first is this PV diagram and the second is TS diagram. So whatever the changes are taking place when the steam is passing or the water is flowing through the different components in this power plant, we are going to represent that in PV as well as TS diagram. So now let's start with the first process. So here you can see if we consider process 1 to 2, which is actually the turbine process. So here we are actually having an isentropic expansion process. Here the expansion of steam will take place in the turbine, and as a result the pressure will drop sharply from P1 to P2, and this can be seen in the PV diagram as well. So here comes this process 1 to 2. So we will just discuss about why these three lines are given in this PV diagram. But first we will understand all the four process, and then we will see what this 1 dash and 1 double dash as well as 2 dash and 2 double dash indicate. So right now you just consider this middle line, that is the process 1 to 2, where there is sharp drop in pressure. So this P on vertical axis we are having pressure, and with the help of arrow you can easily understand that there is a sharp drop in pressure. So this point 1 is prior to the turbine and this point 2 is after the turbine. So here we are having a sharp drop in pressure, and this drop in pressure is converted into mechanical energy, which is further fed to the generator for producing electricity. Again here we can see in TS diagram, that is the process 1 to 2. So this line is exactly perpendicular to the x-axis, which indicates that this process is an isentropic process. Now if we move further for the second process, that is process 2 to 3. So in this process 2 to 3, as we have already discussed, the heat exchange process will take place. So this process is also called as isobaric heat rejection. Here we can see the process 2 to 3. Here it is called as isobaric process since the line is perpendicular to this axis. Again, in this TS diagram, if we look at this diagram, that is process 2 to 3. So kindly we have to note that here, though it does not seem that there is drop in temperature, but one should understand that there is reduction in, or the latent heat is absorbed during this process. So thus the heat will be exchanged with the cooling water, which is further fed to the cooling tower. So after this process, The next process is represented by 3 to 4, which is nothing but isentropic compression process. So in this process, the feed water is pressurized using a pump, which then finally enters into the boiler. And here some work is required in order to circulate the water from condenser back to the boiler. Then the next process is process 4 to 1. So here we call it as the isobaric heat addition process. So here water is heated again at constant pressure in the boiler so that it is converted into steam, and then again this steam will be supplied to the boiler. So now if you look at the PV and PS diagram, then you can see the process 3 to 4. So here we can easily understand that there has been a rise in the pressure. So this line indicates the process 3 to 4, where we are going to use the pump. We are going to provide some input power for the operation of the pump, and as a result we are increasing the pressure from P3 to then the process 4 to 1, which is indicated by this line 4 to 1. So here you can see the boiler process, which is at constant pressure. So here again heat QA, this QA heat, as we have discussed earlier, it is shown here that QA amount of heat is added during this process. Then here also we can observe that process 3 to 4. So here with the increase in pressure, there is also a slight increase in temperature. Work is done during the process 3 to 4. Then comes the next process, that is process 4 to 1. So here we can see that there are two parts, that is 4 to 5 and then 5 to 1. This line 4 to 5, it is nothing but we call it as sensible heating. So whatever heat is absorbed in the condenser, the temperature of the steam coming from the turbine will be reduced, and due to that heat exchange process, the temperature of water will be below the saturation temperature. So this 4 to 5 will indicate that we are increasing the sensible heat of the water, and after increasing sensible heat, we are going to increase the latent heat, that is phase change process will start occurring in the boiler. So as we know, the purpose of the boiler, where we are feeding the water, in this with the addition of heat we will be converting the water into steam. So this process 5 to 1 indicates that we are adding the latent heat into the boiler to the process 5 to 1. So in this way the power plant consists of 4 different cycles that we have discussed now. Now coming back to these 3 lines which are indicated here. So basically all these 3 process we have discussed process 1 to 2. So this 1 dash, 2 dash, as well as 1 double dash and 2 double dash are similar to this process. Just the thing is that we have to consider what quality of steam we are having at this point, that is at point 1, where the steam is entering into the turbine. So in our previous lecture we have studied there are different types of steam, that is it may be saturated steam, wet steam, or superheated steam. So depending on the quality of steam, we are having these 3 different process or 3 different curves, which are indicated by 1 to 2, or either by 1 dash or 1 double dash. So if we are having saturated steam, then it is indicated by process 1 to 2, which we were discussing right now. If we are having wet steam, then the process is indicated by 1 dash, 2 dash, that is this first line. However, if we are having the superheated steam, then the process is indicated by 1 double dash and 2 double dash. So just to kindly note that we are having these 3 different lines or curves because of the reason we are having different types of steam. By considering the quality of steam, we can just have one process out of these given 3. So now we will see the next point. Whatever we have discussed is just given in this slide. All the process we have discussed now. Now we will go with the next point, that is classification of steam generators. So the definition, the steam boiler, it is nothing but the equipment which is used for producing and transferring steam, which is also called as a steam boiler. Principle of steam boiler: the fluid water contained in the boiler and the thermal energy released by the combustion of fuel, which may be either solid, liquid, or gases, is supplied to the water, and as a result of this, we are having conversion of water into gaseous state, which is called as steam at the desired temperature and pressure. This is the working principle of steam generators. Now we'll see the classification. So we will discuss the important classifications or how the boilers are classified. The first classification is based on relative position of hot gases and water, or we can also call it as according to the contents in the tube, because most of the boilers are having tubes inside it, so you can just refer these figures. So based on this classification, we are having two subtypes, that is water tube boiler and fire tube boiler. If we consider water tube boiler, then we just need to understand that inside the tubes we are having water, and outside the tubes we will be having flue gases or high temperature air flowing over the tubes. So if we are having such kind of arrangement inside the boiler, then it is called as water tube boiler. So here in the figure we can see the blue color represents that water is supplied at the bottom and it is converted into steam by the end of this tube, and these tubes are placed inside the container, and we can see the container is full of hot gases. So inside the tube we are having the water, and outside the tube we are having flue gases or hot gases. So as a result, heat will start entering by conduction, convection into these tubes, resulting the rise in temperature of the water, causing it to convert from water to liquid, water to gaseous state. So we will be having here steam. On the other hand, if we consider the fire tube boiler, then it is just the reverse of what we have discussed now. So inside the tube we will be having the flue gases or hot gases, and outside the tube we will be having water. So the container, which is represented by blue color, we are supplying the water at the bottom, and due to the heat which is available inside the tube, this heat will be transferred to this water, and as a result temperature of water will increase and it will be converted into steam. So depending on the contents in the tube, we will classify the boilers into these two types, that is water tube and fire tube boiler. Now we'll see the next classification. So the second classification is based on method of firing, which is again classified into two types, that is internally fired and externally fired. So we can see here the differentiating points in between these two types. So if we consider the internally fired boilers, then basically the classification is based on where the furnace is provided. If the furnace is provided inside the boiler shell itself, then it is called as internally fired boilers. Whereas if the furnace is provided or kept outside or under the boiler, then it is called as externally fired boiler. So here the boiler shell is placed outside the furnace. Then the next classification is based on the pressure of steam. So again we are classifying it as high pressure and low pressure boilers. So if the boilers are having the capacity of producing steam of 80 bar and above, then it is called as high pressure boilers. Whereas the boilers that are having a capacity of producing steam lower than 80 bar pressure, those are referred to as low pressure boilers. Again, the next classification is according to the method of circulation of water. So it will be a natural circulation or forced circulation. So if we are having several types of boilers, which we are going to discuss in our next lecture. But if there are a few boilers where natural circulation takes place due to gravity. So in that case, we call it as natural circulation boiler. The main working principle we can refer to as thermosiphon effect. in those types of boiler. And the example of such type of boiler is Babcock and Wilcox boiler. We are going to study that in detail, how the natural circulation take place. However, if the boilers are having some kind of pumps for circulating the water or steam into the boiler or different parts of the boiler, then such boilers are referred to as forced circulation boilers. And the next type of boiler, that is according to nature of service to be performed. Again, we are classifying it into two types, that is land boilers and mobile boilers. So, if the boilers are installed and which are fixed at a particular place, as we can consider the previous example of thermal power plant, then in such applications, the boilers are fixed to at a one particular place. So, such type of boilers are called as land boilers, where the position of boiler cannot be or the location of the boiler cannot be changed. Whereas in case of mobile boilers, these boilers are having such applications where they are transferred continuously. And the best example of such type of boiler is the boilers that are used in locomotive applications or marine applications. So here the boilers are fitted on mobile carriages and they are called as mobile boilers. So with this, we will stop here. In the next lecture, we will see how we are relating whatever the classification we have seen in today's lecture. Based on the same classification, we will understand in detail what are the different types of water tube boilers as well as fire tube boilers, how the circulation of water takes place inside the boiler, and again, we will also see what are high pressure and low pressure boilers. So for now, we will stop here. Thank you.